I'm David Essex, and this is Enterprise Apps Unpacked. One of the big questions about AI is whether it destroys jobs. Maybe the most important question is what happens to the people whose jobs have been taken over by AI. We've touched on the issue a few times on the podcast, and today we approach it from an unusual angle that points to a more hopeful prognosis. I'm not ready to count on the reassurances by many companies that most people will be shifted to higher valued work that only humans can do and be trained for that still mostly undefined work, or at least be trained on how to use AI in complementary ways. I hope I'm wrong, but it seems just as likely most corporate leaders and investors will find the financial benefits of AI automation too compelling to resist. I've never forgotten something one of my first bosses said. When you cut expenses, it goes right to the bottom line. My fear is companies will just go for the savings from employing fewer people. We saw this in layoffs before we even knew that AI was real, let alone that it could do useful work and start to replace people. But what if AI can do jobs that not enough people want? Take manufacturing. Young workers are less attracted to factory work than older generations were, which has led to labor shortages. Not having enough workers means production lines sit idle and fewer goods go out at slower rates, which can put a company out of business. It's only gotten worse as the reshoring and onshoring trends bring more of those jobs back to North America at the same time baby boomers retire in droves. Alex Sandoval, CEO of Allie, says his company's AI co-pilots can help with this brain drain and attract more people to manufacturing. He has a vision for using AI to capture the know-how of experienced workers, keep production lines running, and prepare new workers for jobs that will mostly involve using this advanced technology. Allie does a lot of other things. Its main business is a data analytics and AI platform that integrates information like production orders from ERP and MES systems with data coming from machines, cameras, and other equipment to provide real-time monitoring, decision-making, and optimization of factory operations. Factory GPT software distills the analytics, and an AI copilot makes recommendations or automatically adjusts the process. You can see why that system could be used to capture people's know-how and make it available to others. We discussed how it all works, what it means for jobs, how it's even possible to capture in software years of work experience, and why that won't necessarily just lead to more job loss. Don't forget to rate, review, and subscribe to Enterprise Apps Unpacked for the real story on the software that runs your business. Alex, I have to welcome you to the podcast. Thanks for coming today.
Thank you, David, for having me. Very excited to be here.
First, can you set the scene and describe the business and societal trends that you're seeing, such as the reshoring movement of manufacturing back to North America, the retirement of the baby boom, that have led to the idea of using AI to capture and transfer knowledge of those workers?
Yeah, absolutely. I mean, I think let's first analyze when we think about manufacturing. We're at a time where, for the first time in many decades, really, manufacturers aren't just asking how do we produce more, but they're asking how do we preserve the know-how of workers that are leaving our organization. And that is really happening because of two things. One is you have younger generations of recent grads who are really doubtful and not really joining the manufacturing workforce. Only 1 in 4 recent grads would even consider a job in manufacturing. At the same time, that's converging with baby boomers and the older generation that is now retiring from manufacturing. And the problem is that a lot of decades of hard-earned knowledge rests in the head and the brains of these workers. When I go to factories and I meet the plant managers, I meet manufacturing directors, they are people that almost can hear a sound of a machine and know exactly how to fix it. And that's really because of all of this sort of nuanced tribal knowledge that they've acquired over the years. And it's very hard to pass that down from generation to generation. So I think that's one of the biggest sort of drivers into why AI is becoming so critical in how to store this muscle memory of modern factories by capturing not just steps, but really wisdom of these workers.
Mhm. So, how would this work? What would be the role of the AI co-pilots, and what's the role of the workers to ensure that the workers' know-how is somehow preserved and made transferable to younger workers or to future hires? What do the workers, especially also their employers, have to do differently to make sure this happens?
Yeah, absolutely. Well, I think there are three things that are important in how AI helps and is trained to be able to guide people into what's the next best step, what's the next best action in the manufacturing context. So the first thing is being able to capture workflows. So workflows is any system, whether that is as archaic as an Excel or as modern as a enterprise application where some of the actions that manufacturing workers take is registered and stored. That's a big part of it. So if I'm using Excel to capture, for example, a maintenance order, and I'm capturing some commentary on how to fix a certain component, all of that needs to be saved somehow in a system. At the same time, there's a lot of what we like to call tribal knowledge, which is nuanced knowledge that very specific workers know on how to fix a machine or how to resolve a process. And all of that typically actually happens in informal channels. So it can happen on Slack, on messaging apps, even in informal water cooler conversations. And all of that is information that also needs to be stored in some way so that, you have all this knowledge within your base. And, now you have all these tools where you can record conversations. Those conversations get transcribed, and that transcription now is built into a knowledge graph. Now, so you have workflows, you have tribal knowledge. Those things come together where AI now understands what is the path of resolution from point A to point B. And at the same time, it's fed with context. So all of this knowledge is now used to contextualize what's the next best decision in my workflow. And that could really be applied to a lot of departments within manufacturing, from quality to production to maintenance to continuous improvement. So this is really how AI works. It's understanding memory, understanding context, understanding workflows, and really guiding and surfacing real-time insights into what is the step with very prescriptive recommendations on what to do for each of these teams.
So you've really done a good job of describing the difference between like the linear process, which strikes me as the kind of easier stuff, for lack of a better word, and then the
Yeah.
tribal stuff that AI also now knows how to handle. Is what you just described, is that what's capable essentially of kind of capturing the experience of the older workers and their ability to solve problems quickly and perhaps have the AI do it, or as you say, the new worker, that quicker answer that, it normally would take 20 years of experience to get.
Yeah, absolutely. I think really the second component, the tribal knowledge and having the ability to be able to capture that, right? And how do you capture that? Well, we've solved it by listening in on conversations, and that means by installing software that is actually listening informal conversations, whether that is messaging, whether that is an informal meeting, obviously with the consent of workers, right? Because ultimately all of this is going to serve not to replace workers but to augment the ability to be able to reason and make decisions. As manufacturing processes get more complex, like when you think about process manufacturing, right, where like food, beverage, pharma, you have thousands of SKUs. Every time there's a different SKU, you have new parameters that need to be controlled. One line can have over 10,000 parameters that need to be controlled and set. So it's really tough, for, even for the very experienced workers to be able to store all of this information and be able to, very quickly respond every time I'm changing a product or every time I'm changing a recipe. Now, with the help of AI, a worker can now manage multiple things in parallel. So they almost have developed like superhuman abilities, and in that sense can control a lot more lines, a lot more scope. These are mission critical workflows, and one mistake, can cost millions of dollars. So, I think by no means is the objective here to let AI to make absolutely every decision. A lot of how AI is working now is, it goes through human review, human approval, but now AI just gives you the opportunity to manage 10x the amount of work that you had previously been capable of.
Yeah.
And really that's what is the value proposition here for manufacturing leaders and manufacturing workers.
Mhm. Factory jobs were among the first to be automated. And I was thinking the other day, you really have to go back to the Industrial Revolution when you talk about when machines began to do some of the work that people did essentially by hand. But then we had robots, and we had much more industrial automation and conveyors and all that, and this more complex system. And then, relatively more recently, we've had AI added to the robots and to the systems in there. So there was definitely, during these different automation phases, there was definitely some job loss. But the other thing that happened was that the nature of the existing jobs changed and some new jobs were then created because of the technology. Is this particular application of AI copilots in manufacturing that you advocate likely to play out in similar ways, or could this time be qualitatively different? Maybe because we're talking about capturing knowledge and not just having the machines take over some of the physical tasks.
Absolutely. Well, this time it really isn't about a machine taking tasks away. It's about machines keeping experience and knowledge alive and shared between the different nodes of machines that are participating in a process per se. So I think what we're really seeing when it comes to jobs, we are seeing uh, you know a, a transition in the jobs that we see at factories, and I think it's okay to be very transparent. The same jobs that you had seen on, very repetitive, manual, mechanical tasks at machines, those jobs are definitely going away. And the new jobs are, how do we capture data that is coming from the machine? How are we structuring it? How do we organize it? How are we capturing this knowledge? How are we building this knowledge into a knowledge graph or nodes of knowledge that can very easily be understood by AI? How do we build and train models that are predictive in nature or that optimize processes? Um, so we have a lot of exciting new opportunities. However, in order to really capture that value, two things need to happen. One is we need to really get the younger generation excited about manufacturing and to realize that manufacturing is 30% of the world's global GDP. It's a sector that is no longer what they had perceived in their head of, clocking in and clocking out and doing very manual labor. It's, probably one of the most exciting careers right now because it's applications of things that you can actually see real world impact. You can see um, millions, billions of dollars of your work really having like a tangible outcome. And that's really exciting. And at the same time, we need to make sure that the organizations of today really get prepared and build that foundation from a data standpoint, from a knowledge standpoint, that allows them to maximize the value that they can get out of AI. That foundation needs to be set by current orgs. And if these two things happen, then, I think we're going to have an exciting time ahead.
Mhm. The problem you're trying to address is in many ways a training issue that companies have already been addressing by having older workers actually train newer workers on the job or in classrooms, but also through some of the workplace learning technology, the more recent technology like online videos, much of which is coordinated and administered in a learning management system. So I'm curious, how does using AI Copilot specifically for knowledge transfer and skills development fit into these existing workplace learning technologies?
Yeah, absolutely. Well, I think they have to work hand in hand, right? On one hand, what an AI copilot or an AI decisioning layer is really doing is just capturing knowledge, capturing information, capturing signals, and being able to then train a model to be able to make those decisions to improve a specific outcome. Now, all of these things, the skills that are required to be able to interact with AI, for example. How do I prompt AI correctly? How do I um, structure the data or train an AI model? All of these things need to be learned, especially for the workers that are currently in these orgs. And learning platforms are a great tool to be able to do that. I think there's a new, or it's not really new technology per se, but a newer application, which is also being able to use AR and VR in the context of learning, because a lot of what we learn in factories really takes into account your geospatial uh characteristics, right? How do I move? How do I uh turn this knob? How do I press this specific button? So when it comes to AI guiding me, I also need to understand the context, the 3D context of where I'm doing these actions. So I think that's also a technology that I'm seeing a lot in sort of uh the new age learning platforms, where they don't just give you the action, but they actually teach you in a 3D environment how to go about to and
Mhm,
execute them.
mhm. If we could return for a minute to the issue of the younger workers and the almost desperate need to attract more of them into manufacturing by, first of all, I guess, making them aware of what manufacturing really is like now. It's not their fathers or grandfathers' manufacturing.
Yeah.
How can your vision and the way your company Allie uses AI, how could that help with this workforce issue of trying to entice more younger workers into the manufacturing world?
Well, I definitely think, as you said, we have to reframe factory jobs and position new factory jobs as data driven, taken out and tech enabled jobs with real world impact. I think a lot of younger generations are really, really seeking for, how do I make sure that the skills I'm applying to my job is translating into real world impact, right? And that's a big driver for a younger generation. And sometimes, when you work on other applications that don't involve real world things, it's not always as easy to connect those dots from my skill down to what that real impact is. In manufacturing, it happens almost to the minute, right? Any change that I can do in a model of just being more efficient is actually translating into a better product that I can physically see down the line. And not just, talking about impact from an efficiency and financial gain, but actually a big impact we're also seeing is from an energy standpoint, right? The ability for these systems to be able to consume energy, well, first track energy, and then being able to optimize energy consumption from water, from gas to electricity that, more so are going to become more scarce in an AI world. That's also a big part of what these new jobs can do. So I think our job really, as the people that are working in technology in the front line, we have to highlight all of these cases, right? What are the real world use cases? Who are the new profile of workers in supply chains? And we need to do that very quickly, because there's going to be millions of jobs that are available now, like today, in the US job market across the Americas, and those jobs are not being filled up, and it's urgent. I think if we really want to institutionalize and reindustrialize America, we need to have newer generations of workers really being excited to work in this industry.
Mhm. Your company, Allie, is in the business of using AI for exactly this purpose. Can you give a quick overview of your products and where they fit into the typical manufacturing IT ecosystem, especially ERP and manufacturing execution systems?
Yeah, absolutely. So when you think of manufacturing, you have several layers. In the stack, you have your business layer, which is your ERP, your SAP, your Oracle, your Microsoft. Then you have, when you go down to the factory itself, you have what you call the MES, which is your execution layer, what you use to sequence planning orders, to direct them to the right lines, and to be able to track execution of those orders. What we're doing is we call it the intelligence layer. And or the decisioning layer. Now, we have a ton of signals in manufacturing, from production orders to machine signals, both from a process standpoint, like speed, temperature, pressure, to a machine health standpoint, like vibration or motor speed. And all of these signals are getting, uh, I guess, more and more and more convoluted in this huge database that manufacturers are currently not exploiting. They are just sitting in separate systems, whether it's your ERP or your execution layer or your SCADA, which is, your aggregator of machine signals, and they're not really being used to help workers make decisions. So really, that's where we come in. We aggregate all of these data points coming in from the ERP, the SCADA, the MES, which are categories of machine health, process health, production data. And we use those things in combination with knowledge, right? In combination with these unstructured data sets that's coming from workers to be able to train models that will help you make decisions on very specific outcomes. I want to reduce rejections in my bottling line. I want to improve yield in my food processing line. So I train models to be able to follow and train people on what are the right decisions to be able to help me reach this specific outcome. And that's really where we come in.
Mhm. How do companies go about actually implementing the copilots? For example, I'm curious about how much work companies need to put into getting the copilots that fit their unique needs or particular needs. Do you need to hire a consulting partner to do it, or Allie's own development and support teams, or can they do a lot of the work in-house themselves?
Yeah. Well, I really think it's a combination of both. I think companies, from a strategic point, need to decide whether they build or buy. I think that's a key thing, right? I think traditionally manufacturing companies have not been incredible at building because it's not a core skill. If you look at projects, over 75% of uh, projects that are homegrown end up failing. And the most successful projects are the ones where you go and seek external support for. And the reason is very simple. It's the technology is advancing at such a rapid pace that very large organizations are not exactly known for being fast moving. By the time you finish a project, the technology is already a year outdated by a factor of two. That's one. And the second thing is technology is not necessarily their core skill. They're great at producing, real things, but not necessarily they're great at atoms and not necessarily great at bits. And, coming in with a partner is great, but it's really, a team play, because you need to have all of this process know-how that is coming from the process engineers, the frontline workers, in conjunction with the IT teams, the OT teams that are really the experts in the network, in the data, in the infrastructure that company has. And then you bring in, possibly a partner to help you come in and train. But what are a lot of these projects sometimes seem very far-fetched and they seem very scary, frankly. And what I want to communicate here is I think a lot of manufacturing companies just need to start small and iterate. Pick a use case that is very painful today. Maybe that is a reprocessing or a rejection rate in a very specific line that is costing millions of dollars. You analyze, okay, why is this happening? You analyze what are the data points that are critical to solve this problem, instrument that, get that in a data layer, and then be able to take, whether it is machine learning models or an agent architecture to help you make those decisions. And there's a lot of tools out there in the market. Of course, we work in that, but there are hundreds of other partners that can help you. And I think that would be my recommendation, because of how fast the technology is moving, to really get yourself the right partner to be able to structure the data correctly, ingest it correctly, also train correctly, so that you have the best possible outcome here.
Mhm. Allie has major food and beverage customers, including Pepsi, Coors, and Heineken. Can you give an example or two of customers who are using your AI co-pilots to preserve the knowledge of their workers and, especially the ones that are nearing retirement?
Yeah, absolutely. So when you think about food and beverage processing, you have decades really of recipes that are being passed down and refined to be able to have the highest quality product. These recipes are by all means extremely complex, right? Because think about making a beer. Um, Making a beer, even though it seems very very simple when you look at the product, the amount of technology that goes that happens behind the scenes from a brewing standpoint. There are thousands of process variables that need to be controlled so that the brewing happens in the right mix at the right time, at the right pace, at the right temperature. And then you have processes from filling beer to capping it, to labeling, to palletizing, that have other hundreds of process variables that need to be controlled. Now, what happens when we fail? So say, if you're making a carbonated beverage, say you don't have the right amount of CO2 when you are, making a carbonated beverage. So you either have an excess of foam or a lack of foam. And those, if you have an excess of foams, you can have things as catastrophic as a bottle exploding, right? In the manufacturing line. So all of these variables are extremely important. Now, how how do these workers contextualize these variables? And really, here's where you have a lot of almost physics and chemical rules that come into play. So if X goes up, then Y goes down, right? And those are very specific rules that only apply to that process, to that manufacturing line, and that is known by these workers. So these things need to be contextualized for a model to be able to understand the data correctly, because a model needs to understand what's the relationship of this machine to this machine. How does this temperature affect this speed, right? And this interconnectedness and of machine knowledge and data relationships is what the workers really need to be able to explain to a model so that it makes the right decision. If you just throw data with giving it no context into a model, it won't know what to do because it's going to be missing out on all of these rules that come into play in the manufacturing context. And that's how um, ultimately, decisioning is the most effective.
What's next for Allie in terms of new technology or maybe use cases that you have your eye on?
Well, we're particularly excited by, this concept that we call closed loop automation through AI. And what that means is you have a process that in a closed loop way, meaning you take the data from the machine, you train the model, you you deploy that model to be able to decision, but then the technology actually connects back to the machine to articulate what that change is. So you actually only have a human approve it from outside the loop, right? You don't have to have a worker physically going into a line, putting themselves maybe at danger to go and move a knob or adjust the temperature. Now a model can do that completely on its own. I think when we think about the equivalent in the real world, I think this would be, very similar to autonomous driving in that you have real world data points, right? That a model is taking that can be visual in nature, but they're coming from the real world. You are receiving all these signals and you're training a system to be able to take these signals from the real world and exert it into a control system. So really that's what we're doing. We're taking signals from machines. We're taking signals from the environment. We are ingesting those data points and then training models to go back to the machines and exert decisions on control systems. So that's truly what we're particularly most exciting about, is sort of building much more autonomous manufacturing systems that are able to auto adjust in real time.
Do we have a shorthand phrase for that? Is that like human kind of in the loop, or is it still human in the loop?
Yeah, it's still a human in the loop. Look, I think humans are always, because of how important these decisions are and how costly, uh, a human always needs to approve them, right? If a model makes a $50 million, you know, decision that, ultimately results in a $50 million loss, who's who's responsible, right?
Right. Yeah.
so so I think even from a liability standpoint, humans need to be approving these things. And when you look at the more advanced use cases, I think that's the world we are going to be living in. Like we're going to have these superhuman workers that are going to be managing a number of agents. Like today you have managers managing junior members of a team. Today we're going to have superhuman workers managing agents. These agents are going to go in, you're going to train them, you're going to tell them exactly what you want them to do, you're going to give them objectives, you're going to give them constraints, and they're going to go and act. They're going to go to your supply chain, they're going to make decisions. And what a human needs to do is go start reviewing these decisions, right? You agents are going to go, they're going to work, you're going to come back the next day and you're going to have 20 things that you need to approve and review. You approve and review them, they go back, they continue working. And that's really how I view, the next 10 to 20 years is you are going to have humans that are going to be almost like code reviewers and approvers of agent work and agent workflows. And that's exactly what I envision for supply chain and the manufacturing industry as well.
Hmm. Yeah, that sounds pretty good, actually. Well, Alex, thank you again for coming on the podcast.
No, David, thank you. It was a true pleasure to talk about manufacturing tech with you, and we're happy to join back anytime.
Hmm. Thank you. Thank you for listening to Enterprise Apps Unpacked, where we give the real story on the software that runs your business. To learn more about business applications, explore our content on searcherp.com. Find us on YouTube at our channel, Eye on Tech. Subscribe to our podcast to receive the latest episodes as they drop. And if you liked what you heard today, give us a rating and review on Apple, Spotify, or wherever you're listening. Until next time.
Podcast programming and promotion by Kelsey Waddell. Music supplied by DP via Getty Images. This is an Informa TechTarget production.